Hello, greetings mga ka-spacers natin out there. Magandang araw po sa inyong lahat. This is your ka-spacer and space commander, Professor June Cajigal. Now, in today's video, we will answer that question, what makes a planet habitable? Now, many astrobiologists believe that if we find living organisms on other planets in our solar system and elsewhere in the universe, they will be recognizable to us as life. Now, a planet's habitability or the ability to harbor life results from a complex network of interactions between the planet itself, the system it's a part of, and the star it orbits. The standard definition of a habitable planet is one that can sustain life for a significant period of time. And as far as researchers know, this requires a planet to have liquid water. Now, to detect this water from space, it must be on the planet's surface. The region around the star where liquid water can exist on a planet's surface is known as the habitable zone or the Goldilocks zone. However, this definition is confined to our understanding of current and past life on Earth and the environments present on other planets. As researchers learn more and discover new environments in which life can sustain itself, the requirements for life on other planets may be redefined. So mga ka-spacers, let's watch this video about what makes a planet habitable. Alright mga ka-spacers, let's watch this. Now, in order to understand the role of life in the universe, we must explore the range of environments that might support living things. So, our search for life beyond our planet is informed by what we know about life on Earth. And life as we know it here on Earth requires the following, such as liquid water, that's very obvious. We need also some form of energy such as sunlight or probably heat from volcanic activity. We also need access to organic compounds such as carbon compounds. And also we need a stable environment such as time to originate and to evolve. Now, because of these requirements, in order for life to exist, our search for life outside planet Earth has become the search for water. The search for life outside Earth has become the search for water. Now, what is the case for water? Ano ba ang meron sa tubig? Now, water is special. Water exhibits certain properties that allows it to sustain life. And one of those properties is cohesion. Now, by definition, cohesion is the attraction of like molecules. Now, water molecules are attracted through hydrogen bonding. And because of the hydrogen bonding ability of water, water is quite cohesive, as you could see in this demonstration. So you can add several drops of water in that single penny. So this demonstration shows how cohesive water really is. Now, another property of water that is essential to life is adhesion. Now, adhesion is the attraction of unlike molecules. Now, in the case of plants, water molecules are attracted to the xylem vessel wall. And together with cohesion, water is transported from the roots to the stem and to the leaves of plants. And this is what we call as capillary action. Now, another special property of water is surface tension. Now, surface tension is the ability of water molecules to form a thin film. And this thin film of water molecules will allow certain objects to literally float on water, like this paper clip. So this paper clip is supported by the thin film of water molecules. So that is surface tension. And even animals can harness that surface tension of water, so that animals such as this spider can literally walk on water. Now, another property of water that is essential to sustain life is that water has a high heat capacity. Now, what does this mean? Now, it simply means that water can absorb a great deal of heat. So, we have here a demonstration to show the high heat capacity of water. So, what we have here is a water balloon. So, if you apply heat on a water balloon, that water balloon will not pop or it will not burst, simply because the water inside the balloon absorbs that heat from that flame. So isn't that fascinating that water has a high heat capacity? And because of water having a high heat capacity, this is essential to life here on Earth. Now we know that our Earth is covered with about 60% water through our oceans and seas. So our oceans acts like a tremendous heat sink in order to moderate our global temperature. So that's the importance of water having a high heat capacity. Now, another property of water which is essential in sustaining life is that water expands as it freezes. So if you'll get a glass container and fill it with water up to the brim and place it inside the freezer, then as water turns into solid, water expands, and as a result, your glass container will break. So what is going on here? Now, because of the hydrogen bonding ability of water, water becomes less dense as it turns into solid than it is as a liquid. And as a result, ice floats on water. And since ice is less dense, it forms on the surface at first. And as water freezes, it releases heat to the water below and insulates it. So that's why our oceans and lakes don't freeze solid. Now, the expansion of water upon freezing is vital to life on Earth. It is what causes ice to be less dense as a solid than as a liquid. This means that ice floats in liquid water. Ice is less dense than liquid water at 4 degrees Celsius. This may not seem like a very important property, but the fitness of the environment would drastically change if water was less dense than ice. All bodies of water would eventually freeze over if ice did sink, eventually making life on Earth impossible. If the river froze from bottom up, fish and other animals would not survive. However, if the frozen water floats, the fish will have a much better chance of survival. Now, aside from the search for water, another thing that we need to consider in our search for extraterrestrial life would be the so-called Goldilocks Zone or the so-called habitable zone. Now, what is the Goldilocks Zone or habitable zone? Now, the Goldilocks Zone is the distance around the sun supporting life. And in the case of our planet, our distance of 93 million miles from the sun is just right to support life. So that means that our Earth is lucky to be in the right place for life to exist. Now everybody imagine this. Now if our planet would be close to the sun, let's say that of the planet Venus, then our planet would be too hot. So our oceans would boil up and life would be impossible. Now imagine if our planet would be far from the sun, let's say that of the planet Mars, then our oceans would turn into ice, water would exist in solid form, and life would be impossible. So this distance of 93 million miles from the sun is just right for life to exist. Now I mentioned something about Venus and Mars. Now these planets, they exhibit extreme environmental conditions. Now the question is, can extreme environments like that of the planet Mars support living things? Now what do you think? Alright, so the answer is yes. Extreme environments can support living things. Why? Because life can find a way. Alright, and there are creatures that can live in extreme environmental conditions. Here on Earth, we call them extremophiles. Extremophiles, these are organisms that can survive in extreme conditions. Alright, so we have here examples of extremophiles like halophiles. Halophiles are organisms that can live in extreme salt conditions. Or we have acidophiles. Acidophiles, they can survive in extreme acidic conditions. And we have thermophiles. Thermophiles, these are organisms that can live in extreme temperatures. Now, I want to focus on this fascinating creature known as Deinococcus radiodurans. Now, one of the most surprising cases of tolerance to extreme conditions is exhibited by this bacterium known as Deinococcus radiodurans, which is found in the cooling water of nuclear reactors. So this bacteria can tolerate high radiation. Now, isn't that fascinating about Deinococcus radiodurans? These bacteria can survive even in high doses of radiation. Now, another fascinating creature that I want you to focus on are the tardigrades or water bears. Now, the tardigrades, they are typically 0.5 millimeters in length. And would you believe that they can survive virtually in any extreme environmental conditions, even in the vacuum of space? Now, these tardigrades, they can live anywhere on Earth, in the frigid peaks of the tallest mountains, the cauldrons of erupting volcanoes, and in the deep ocean vents at the bottom of the sea. So, if we would bring a tardigrade to the moon, these creatures will survive. And if we would bring the tardigrade to the planet Mars, then this creature will really survive on the Martian surface. So isn't that fascinating? Now, are you not fascinated about the tardigrades? Now, if so, please let us know. Kindly type in your reactions or even your comments or questions in the chat box or comment section. We would like to hear from you. Gusto namin malaman ang inyong mga reactions about this fascinating creature. Now, life as we know it here on Earth requires liquid water, energy, nutrients, a habitable zone to survive. And also we mentioned that life can withstand extreme environmental conditions such as the tardigrades and even Deinococcus radiodurans. Now, what about life as we don't know it? Now, before we answer that question, I will transfer to another place. So while waiting for a few minutes, please type in your reactions or your comments or even your questions about this part of the lecture. Alright, so Scotty, beam me up. Energize.
What makes a planet habitable? There are many planets in the entire universe, but as far as we know, there is only a handful which could possibly support life. Space scientists and astronomers continuously scour the vastness of space to find signs of life elsewhere in the solar system, and even outside of it. Now, taking one celestial body at a time, devoting all your time and resources to ascertain whether it supports life, would be too imprudent and wasteful. That's why astronomers look for certain pointers in a celestial body and then determine if it has the potential to support life. In other words, whether it's habitable. So, what are the requirements for a planet to support life? Are there more habitable planets? These are some of the questions which we will explore today. For years, there has been a great deal of talking about finding liquid water on Mars and the possibility of life existing on the red planet. All this coverage has resulted in a lot of questions being raised for people always staring out into space, including a few interesting ones. For example, is the existence of water the only condition that needs to be present on a planet in order to host life? To better answer that question, let's look at the various factors that make a planet habitable. Taking cues from Earth. As of now, we do not have any concrete proof of the existence of life anywhere else in the universe. Therefore, in order to establish the criteria of habitability of a planet or a natural satellite, the conditions that support life on Earth also need to be extrapolated for other celestial objects. In other words, since we haven't found proof of life anywhere else, the basic conditions that support life on Earth can be taken as a benchmark for the sustenance of life on any planet. There are a number of conditions that a celestial body must fulfill in order to support life. These conditions involve certain geochemical, astrophysical, astrological, and geophysical criteria. According to NASA, for a celestial body to sustain life, there should be extended regions of liquid water, conditions favorable for the assembly of complex organic molecules, and energy sources to sustain metabolism. When gauging the habitability of a planet, a number of factors must be considered, including the planet's bulk composition, orbital properties, atmosphere, and potential chemical interactions. Some of the requisite conditions are as follows. Astronomical properties. For a planet to sustain life, it has to be a comfortable distance away from a star, such as the Sun of our solar system. Around a star, there's a shell-shaped region of space called the habitable zone, where a planet can maintain liquid water on the surface. If a planet lies in this region, then there are good chances for the habitability of life on the surface. However, if life could exist without water in a certain part of the universe, then the definition of a habitable zone will change drastically. Also, since a star becomes more luminous as it ages, a planet must be farther away from it in the habitable zone to sustain life. Stability of stars. For a planet, it's important that the stars closest to it are stable in terms of their luminosity. Although every star's luminosity increases with time, it should not be too severe, or else it could simply burn up everything on the closest planet. Since Earth is a terrestrial planet and is habitable, it is assumed that a planet must be made up of rocks, not gases. Therefore, we don't expect to find life on gas giants like Jupiter, Saturn, and Uranus. However, there could be life on the cloud tops of these planets. But it's highly unlikely as there is no surface and the gravity of these planets is very high. Mass matters. A planet with low mass is not suitable for habitation because low mass means low gravity. Low gravity further means that the planet won't be able to retain an atmosphere, as constituent gases will easily reach escape velocity and be lost in open space. However, there are some exceptions to this condition. One of Jupiter's moons, Io, is a small celestial body, yet it is volcanically dynamic and has distant chances of harboring life. Rotation and revolution. A planet must also rotate on its axis and revolve around its parent star, like Earth going around the Sun, to be habitable. Furthermore, if life on the planet is to be given a chance to evolve, certain other conditions have to be met in its rotational motion. For example, there should be some axial tilt perpendicular to its orbit, which will result in seasons on the planet or celestial object. A molten core. To sustain any type of life, a planet requires a rapidly rotating magnetic field to protect it from flares from nearby stars. This is what we call the core of the planet. A planetary core is a terrific source of geothermal energy, allows cycling of raw materials, and spawns a magnetic field around the planet to protect it from harmful radiation. It should be noted that Mars was known to have a liquid core at one time, but its heat dissipated quickly because Mars is a smaller planet. Holding an atmosphere. Earth's atmosphere not only fulfills most of our basic needs of providing oxygen, but also keeps the planet warm by trapping carbon dioxide and other gases. It also protects life on the planet by blocking the vast majority of harmful radiation. Therefore, any habitable planet must have all the necessary conditions in place to have an atmosphere, or at least a protective layer of essential gases. As stated earlier, since we do not know the existence of any life outside of Earth, these assumptions are deduced from the particular conditions that support life on Earth. If, however, there are organisms who can survive in altogether different conditions than what we have experienced here on Earth, then who really knows? Maybe we already have company. Are there more habitable planets? Our satellites have been picking up on Earth-like habitable planets for some time now. We've found many planets which seem to fit the bill partially, but them being far away has stopped us from getting any proper evidence. Scientists have discovered planets which have been deemed livable, or we think that they are livable, because they lie in the habitable zone of their respective stars. This means that they could have liquid water and thus sustain life. They also fulfill some factors that have been mentioned. Some of these planets include Proxima B. This planet revolves around the star Proxima Centauri. The star is 4.2 light-years away from the Sun. It weighs around 1.3 times more than Earth. It could have liquid water, but that depends on its atmospheric conditions. But as nothing is known about its atmosphere, we cannot be sure about it having water. Wolf 1061c. It's located in the constellation Ophiuchus and revolves around the red dwarf Wolf 1061. The planet is approximately 13.8 light-years from Earth. It's around 4.3 times larger than Earth. It has a short revolution time of about 17.9 days. Gliese 832c. It revolves around the red dwarf Gliese 832 and is present in its habitable zone. Its size is around 5 times that of Earth. Because of this, it's often called a super-Earth. The planet is 16 light-years away from our planet. Trappist 1d. This planet is around 40 light-years away from us and is in the constellation of Aquarius. It revolves around an ultra-cool red dwarf known as Trappist 1.
Alright mga ka-spacers, so I guess that's about it, and I hope you have learned a lot about that issue on what makes a planet habitable. So if you have any questions or comments or reactions about that video, please feel free to type in your comments, your questions, your reactions in our comment section below. Please like and share this video, and also please subscribe to my channel on YouTube, The Science Guy, Professor June Cajigal, and please like this Facebook page, The Science Guy Kaspacer channel. Alright, so I guess that's about it. This is your Kaspacer and Space Commander Professor June Cajigal saying, live long and prosper. Alright, so see you in our next video. Bye-bye!